We've been talking about ions, monatomic and polyatomic ions, and now we're going to put the ions together into the ionic compounds. Ionic compounds always have two ions. There has to be a positive and a negative. We always list the cation first and then the anion. There's not any big, really significant reason. It's because that's how we decided to do it. Okay? Why on a formal wedding invitation do you write Mr. and Mrs. Tom Jones? Why don't you write Mrs. and Mr.? Because it's just tradition. It's how we've always done it. It's just how you do it, right? Same thing here. Cation first, then anion. Always. And this goes along with the metals being masculine and the non-metals being feminine. The guy goes first and then the girl. So cations first, then the anions. So when we're naming the compounds, we're going to look at the two different ions. We're going to name the ions and then just write their names together. Sometimes you need to identify the charges on the ions, especially if it's one of those metal ions that can have more than one charge. We need to know which one it is. If we need to, we can figure out the charge on that cation by looking at the anion charge and the ion ratio, and we'll go over some examples of that. Then you just name the cation, name the anion, and leave a space between the two names. So it's the name of the cation and a space and the name of the anion. Compound names of any kind are not proper nouns. Don't capitalize them. And then remember, metals that are not in groups 1A, 2A, 3A, zinc, or silver are going to need a Roman numeral to indicate the charge. So let's name some compounds. So here we have CaCl2. So we want to separate this into two ions. Well, this one only has two elements, so that makes it a little easier. We've got Ca and we've got Cl. What are the charges on those ions? The periodic table is our new best friend. Where's calcium on the periodic table? What group is it in?
2A.
It's in group 2A. That tells us the charge on it is 2+. It also tells us that the name of this ion does not need a Roman numeral. Remember, if it's in group 1A, 2A, 3A, zinc or silver, it doesn't need a Roman numeral. So the name of that first ion is just calcium ion. But we're not going to put the word ion in our compound name. And then what about chlorine? What does chlorine do as an ion? What's the charge on it? -1. It's in group 7A. 7 minus 8 is -1. So this is the chloride ion. The name of it, chlorine, change the ending to "ide." And so this is calcium chloride. Any questions? Let's look at this, ZNO. Sometimes you just take a saw and cut it in half. There's two ions. What charge does zinc ion have? 2+. How do we know that? We remember the pattern on the periodic table. Aluminum is in group 3, it's 3+. Zinc is down and to the left, it's +2, and silver is down one more, it's +1. So this is Zn2+, and the name of that is just zinc. It doesn't need a Roman numeral because it's the zinc in groups 1A, 2A, 3A, zinc or silver. What kind of an ion does oxygen form? What's the charge? 2-. And how do we name it? Oxide. Let's do this one. Yeah.
How do you know the oxygen is negative?
-2? Because it's in group 6A. 6 minus 8 is negative 2. Or counting backwards from the noble gases, minus 1, minus 2. Position on the periodic table. Okay, SnF2. Well, cut this in two. I've got Sn, and I've got F. What's the charge on Sn? Where is it in the periodic table? Is it in groups 1A, 2A, 3A, zinc, or silver? No, it isn't. It's over in group 4A under carbon, a couple rows down. It doesn't have a predictable charge. What's the name of the element whose symbol is Sn? Tin. That's one of those that's a little harder to remember. So this is tin. I don't know what the charge is. I know it needs a Roman numeral, though, because I found it on the periodic table. Not in groups 1A, 2A, 3A, zinc or silver. I'm just going to put the parentheses in, and I'm going to come back and fill in the Roman numeral later. F. What charge does a fluorine ion have? Negative 1. Because of its position on the periodic table. And what's the name of it? Fluoride. Remember, there's no flour in there. How can I figure out the charge on the tin? I have to look at the fluoride. Each fluoride ion has a negative 1 charge, and there's 2 of them, right? There's 2 of these, and there's 1 of those. And so I've got a total of negative 2 charge here. I must have a total of plus 2, and it all has to be on that 1 ion. So this must be 2 plus. And so I'm going to put a Roman numeral 2 in there. The Roman numeral is the charge on the ion. It is not the subscript in the formula. Any questions? Yes?
We don't say difluoride or?
Nope. We don't say difluoride. It's tempting. And students try it, and it'll be wrong. Because those prefixes are so easy, right? Like, oh man, can't we use that for everything? No, sorry. Pardon me? The di and tri and tetra are for molecular compounds. So if you have a metal, you can't use them. It's just 2 nonmetals. The reason is we don't need them for the ionic compounds.
So did you say that the subscripts have to equal each other? Or?
The subscripts do not have to equal each other, but the total charge, positive and negative, has to be equal.
Oh, so if one's negative, one has to be positive?
Yeah, you have to have positive and negative. So because there are 2 negative 1 ions, we know that the total negative charge there is minus 2. And so that tells me that the total positive charge has to be plus 2. Because if each of these electrons, if each of these gained 1 electron, it had to get the electron from somewhere. There isn't an electron bank where you can go and borrow electrons. These guys got their electrons from the tin. For every 1 of these atoms, there were 2 of these atoms. These became minus 1 ions because they each got 1 electron from the tin atom. So the tin lost 2 electrons and has a plus 2 charge.
Should the chlorine in the first one have 2 minus?
But there's 2 of them.
Oh, okay.
Yeah. There's 2 of them. So there's a chloride minus and a chloride minus. So total is minus 2 charge and plus 2 charge. And you just have to ask questions and keep looking at it until it clicks. And then you'll go, oh, okay, I see it now. Okay, what about this one? Mn3P2. Well, don't worry about the subscripts at this point, okay? Just look at the 2 different elements. There's Mn and there's P. Find Mn on the periodic table. Is it in groups 1A, 2A, 3A, zinc, or silver?
No.
No. That tells us what? It needs a Roman numeral because we cannot get the charge of that ion just by looking at the periodic table. So let's write its name. That's manganese, not to be confused with magnesium or the fictitious manganesium. That's one of my favorite students make up elements. Manganese needs a Roman numeral. Okay? And then P. Well, what kind of an ion does phosphorus make? Three minus. It's a nonmetal. And so phosphorus, we change the ending of its name, becomes phosphide. So there we have most of the name. Now we have to figure out the charge on that pesky manganese ion. It is going to be +2. Well, here we have 2 of these phosphides. So that gives us a total of -6 charge. And the formula tells us there's 3 manganese ions. Stick the other one up here. If the anions give a total of -6 charge, what does the total positive charge have to be?
3.
It has to be +6. So we need a total of +6. That +6 charge is divided equally among these 3 ions. So 6 divided by 3, they're each going to be 2+. So this kind of math makes some students just squirm in their seats. They're like, yeah, you can't do it. Yes, you can. You're just afraid of it. So let's pretend that the electrons or those charges are cookies, okay? So here we have 2 moms come into the room, and they each have 3 cookies, okay? There's a total of 6 cookies, and there's 3 little boys. How many cookies does each of the boys get? 2. You can do that. Because cookies and moms are friendly, right? You know, maybe it makes you hungry if you didn't get enough lunch. But it's okay. The math here is the same, okay? If you have trouble with it, please keep asking me until it makes sense to you. Because I can explain this a whole bunch of different ways. I've done bowling balls in boxes and all kinds of things. Train cars, buses, people riding in cars and sharing rides. And I'll make up more if those don't make sense to you. But I'm not going to do all of those for the class. Okay? But if you need help with it, please ask. Any questions?
So you knew it was 3 because it says you have 3 manganese, and then you had the 6 charges, and then you wanted to distribute those
Right.
evenly. Okay.
Yep. So I know the charge on the anion because it's on the periodic table, right? And the formula tells me I have 2 of those, and I have 3 manganeses. And so I have 3 of these, and I know I must have +6 charge because of the total -6 charge. So then I just need to figure out how would I divide them evenly. So in this formula, the name then is going to be manganese 2 ion, because each manganese has a +2 charge. Here's some more examples. Now, these are examples with polyatomic ions. And sometimes you look at these, if it's got parentheses, then you're like, oh, yeah, there's a polyatomic ion in there. If you don't have parentheses in there, it can get a little confusing. We're always going to have 2 ions. 2. 1 positive ion and 1 negative ion. There are compounds out there that have, like, 2 different positive ions and a negative ion. We don't do those in Chem 101P, and we don't do them in Chem 1A. So we're just not even going to talk about them. So 2 ions always. So the task then is to divide this into 2 pieces, not 3. People get very creative and they want to call that barium chromium tetraoxide. No, we don't give points for creativity in naming compounds. I know what you mean, but it's silly. It's like my 2-year-old pointed to the cash register in the restaurant and said something about the dollar biller. He wanted to go see the dollar biller. Well, we knew what he meant. He meant the cash register, right? But it's silly. It was silly. And he was 2, you know, that was fine. Now he's 21. If he still called it a dollar biller, we would wonder about him, right? So you're going to make mistakes when you first start naming compounds, but learn from them and learn the correct terms for these. So when we divide these up, look at the first element. Usually you can just take the first element off. The first element is usually a metal. That will be a monatomic cation. Everything else is a polyatomic ion. So I'm going to draw a line after barium. These are my 2 ions. I've got barium, and I've got everything else, CrO4. So barium, what charge does barium have? Where is it on the periodic table? It's in group 2, +2. Because it's in group 2A, it does not need a Roman numeral. So the name of that first ion is barium. That's what you do with the terminally ill chemist. And this is what happens when I don't put... I started putting the graph paper background because I zoom in and I can't see anything else and I drift all over the place. But I left it off on these. I have to put it back. Barium. Now, this thing. Don't get creative. Unless it's got like hydrogen sulfate or hydrogen phosphate, one of those guys, it's got a single name. What would be a good guess for that name? Chromate. We've got chromium, we've got oxygen. Most of those Oxy Acids, you take the first element's name and you put ate or ite on the end. So chromate would be a great guess, and in this case, chromate is correct. And so that's barium chromate. What if you needed to know the charge and you had forgotten the charge on the chromate? Could you figure it out? Yeah. This formula says I have 1 barium ion and 1 chromate ion. I know the barium is +2 from the periodic table, so the chromate must be 2-. And if you look it up in the chart, it is 2-. Okay, let's look at the next one. CuNO2, 2. And that's how we would read that. CuNO2, 2. If there weren't parentheses, we'd say CuNO22. Well, we need 2 ions. Here, the NO2 is actually shrink wrapped. It's packaged in the parentheses. So we'll separate that package from the copper. But again, we're taking that first element off and then looking at what's left. So we've got Cu, and then we have NO2. When I'm looking at the name of this ion, I don't care about the parentheses and this 2 out here. That just tells me I have 2 of that unit. The formula for the ion itself is NO2 with some charge on it. Well, find copper on the periodic table. Ask yourself, is it in group 1A, 2A, 3A, zinc, or silver? No. Therefore, it needs a Roman numeral. So copper needs a Roman numeral, and then we've got this guy. If that was all by itself, we'd call it nitrogen dioxide. But this is an ion. I just haven't written the charge on because maybe we don't remember the charge. Take a guess at it and then check your work until you've got it memorized. If you look this up in the table, it's got a -1 charge. What's the name of it? It's nitrite. Nitrate is NO3-. So this is going to be copper, something in parentheses, nitrite. Spelling is important. Nitrite and nitrate are different substances. And there could be a situation where one's toxic and one's beneficial. So the I or the A there matters. How do we find out what the Roman numeral is? Yeah, we have to look at what's going on here. We've got two of these guys. They're each -1. So that's a total -2 charge. And how many copper ions are in the formula? Just one. So it must have a +2 charge. So this must be 2+, and this is copper 2 nitrite.
So how can you tell that NO2 is a negative?
Because I memorized it.
Okay.
Or you look it up in the table. It's just one you have to memorize. It should be on that yellow card. Isn't it? Or do I need to give you the green card too? Maybe it's on. Yeah, I'll have to get the green card out. Any other questions about that one? HgOH2. Again, we're separating this into two pieces. First piece is usually a monatomic metal ion. So there's Hg and we've got OH. So here I have Hg and I've got the OH. We find mercury on the periodic table. Is it in groups 1A, 2A, 3A, zinc, or silver? No. Needs a Roman numeral. Hg is mercury. Needs a Roman numeral. What's the charge on this ion? And what's its name? It's -1. It's hydroxide. This one you have to memorize. So mercury something hydroxide. I look at the charge on the hydroxide, it's -1. There are two of those, so I have a total of -2 charge. I must have a total +2 charge. There's only one positive ion, and so that's a 2+. This is mercury 2 hydroxide. Yes? Yes, Mercury's weird in so many ways. It's a liquid at room temperature, and it would be really, really fun to play with this liquid metal if it wasn't toxic. Unfortunately, it is toxic. Mercury does form a polyatomic ion, Hg2, 2+, and that is known as mercury 1 ion, which you might be like, well, what the heck? It's on the chart. I don't think of it as something that's super important, but it's out there. You need to know about it. What would be the charge, if you separated this, what would be the charge on each mercury? There's two of them, and together they have a +2 charge. So they each would individually have a +1 charge, and that's why we call that mercury 1, but it's actually a polyatomic ion. That's just a weird one. You can get through Chem 1A just fine. You can get an A in Chem 1A without knowing that little detail. But there it is. How about this one? Now we've got even more letters in there. Again, most likely, just take off the first element, the metal. The first element is sodium. So we've got Na. Then write everything else together as one ion. You don't want to separate this into hydrogen ions and phosphate ions. You want to keep it together. H2PO4. 2 ions. Where's sodium on the periodic table? It's in group 1. So we know it has a +1 charge, and because it's in group 1, it doesn't need a Roman numeral. So that's just sodium. And then we're going to look at what's left. That's a mess. This looks like phosphate with 2 hydrogens on it. That's what it is. It's dihydrogen phosphate. That's the one time you can use a Greek prefix in an ionic compound. Dihydrogen phosphate. If you go look in the table of polyatomic ions, that's in there. It's got a -1 charge. That's in there. Any questions? I'm going to skip that one. Writing formulas of ionic compounds. This is going the other way. Given a name, write the formula. The first thing is to write the formulas for each of the individual ions. There's going to be how many? 2. 1 cation, 1 positive, and 1 negative. Write the formulas with the charges for each of the ions, and then figure out how many of each that you need. We did this part earlier. I gave you the ions and said, how would you put them together? So as an example, let's write the formula for aluminum sulfide. There's 2 words here, aluminum and sulfide. We have an aluminum ion and a sulfide ion. So we need to write the formulas for the ions. So aluminum is Al. We find it on the periodic table. It's in group 3A. It's got a 3+ charge. And sulfur is S. We find it on the periodic table, and we figure out it has a 2- charge. Now there's many different methods for figuring out how these go together. One of them would be crisscross. Take this 3, that's the subscript for the S, the 2 is the subscript for the aluminum, get Al2S3. That's the formula for aluminum sulfide. I don't want to do all of these. We're running out of time. Let's do silver nitrate. What's the formula for silver ion? Well, this element symbol is Ag. And what's the charge on a silver ion? +1. We have to memorize that. 1A, 2A, 3A, zinc, and silver. Aluminum's +3, zinc is +2, silver's +1. Nitrate. It's going to be NO3, and we need the charge. It's -1. Those are so easy to get wrong. I get it. I'm going to look at these. I've got +1, -1. I don't have to do any multiplying or crisscrossing or anything. I'm just going to shove them together, and their charges will add up to 0. And this is going to be AgNO3. I'm going to do this one also. Manganese 2 hydrogen carbonate. There's 2 ions. There's 3 words there, but there's only 2 ions. So manganese 2. The symbol for manganese is Mn, and the charge is just handed to me, +2. Hydrogen carbonate. That's a polyatomic ion. It's HCO3-, because that's what they decided to call it, and we just have to deal with it. So I've got +2 charge, -1 charge. I need 2 of these guys to equal the charge on that one. So the charges will add up to 0. So I'm going to have MnHCO3-2. This is a polyatomic ion. I have more than one. I need to put parentheses around it. Questions? Carbonate does have a 2- charge. Carbonate is CO3, 2-. When I do hydrogen carbonate, I add a hydrogen ion to it. And that's how the charge is reduced. Good question. We're going to get practice with these on a worksheet I'm going to give you. We need to talk about the oxy acids. We talked about binary acids, the acids which are binary molecular compounds dissolved in water. An oxy acid also produces hydrogen ions when dissolved in water, but it's an aqueous solution of a compound that has hydrogen and an oxyanion. Oxyanions are things like the nitrate, sulfate, chlorate, things like that. The names for the oxy acids are derived from the name of the oxyanion. If the oxyanion ends in the ate, you change ate to ic and stick the word acid on there. If the anion names in ite, if the name ends in ite, you change the suffix to us acid. So how do you remember that? I've got a silly sentence. Rick ate him before he could bite us. Rick ate him before he could bite us. I don't know what this creature is, but apparently it's edible. So, ick and ate go together. Ite and us go together. You're welcome to come up with something better than that, but I've been using that for years. Ick and ate. And then when we're writing a formula, the number of hydrogens in the formula is going to be equal to the charge on the oxyanion. So let's do some examples, because just giving you instructions, those never means much. So name these guys. Now, what these have in common is they all start with H, and they all have AQ after them. If it has AQ after it, you really should name it as an acid. When we look at this, it starts with H. That's another clue that it can be an acid. And here we have oxygen. So we're going to separate the H from the rest of it, kind of like we did with those ionic compounds. I want to look at this oxyanion. What's the name of that? I hear some good guesses. It's phosphate. So that's phosphate ion. I'm going to change this ending. Rick ate. Ick and ate go together. I'm going to change ate to ick. So this is phosphoric acid. And in sulfur and in phosphorus, there's the OR and the UR, and they kind of come and go unpredictably. If you wrote phosphoric acid, I would correct it, but I wouldn't mark it wrong. It's kind of hard to remember when the OR comes back. Phosphoric acid from phosphorus. So here we have HBrO2. Again, we've got something that starts with H and has oxygen in it. What do we have if we cover up the hydrogen or chop the hydrogen off? Bromate. Right? Bromate is BrO3. This is BrO2. So this is a bromate ion. What do we change ite to? Us. So this is bromous acid. What we were talking about, the number of hydrogens being equal to the charge. Phosphate has a 3- charge. Phosphoric acid has 3 hydrogens. Because these are hydrogen ions, they're each +1. So to balance out the -3 charge on the phosphate, we need 3 hydrogens. The charge on bromite is -1. And so then we just need 1 hydrogen ion. How about this one? What's the name of the ion there? Perchlorate. Perchloric, yeah, perchlorate is, more caffeine will help. So this is the perchlorate ion, because it has 1 more oxygen than chlorate. Perchlorate. So we change the 8 to ic, and this is perchloric acid. Any questions? Writing formulas, going the other way. This is one of my favorite acids. It looks like periodic acid, doesn't it? What is it? An acid sometimes and other times it isn't? It's periodic acid. So if I'm writing formulas, I'm going to change this ic acid. Ic went with ite or us, or 8? Ic and 8 go together. So this is from periodate. I need the formula for periodate ion. Well, I memorize iodate. Iodate was IO3 minus. Periodate has 1 more oxygen, IO4 minus. And then I look at the charge on that. It's -1. How many hydrogens do I need? 1. So the formula for periodic acid is HiO4. And then just a really nice touch is to put AQ. Just be really clear. It's dissolved in water, it's an acid. Let's do chlorous acid. I change us to what? Rick ate him before he could bite us. Ite us.
Right.
So this is from chlorite. Well, chlorate is ClO3. Chlorite is ClO2 minus. -1 charge tells me I need 1 hydrogen, HClO2. About nitric acid. That comes from which oxyanion? Nitrate. Nitrate is NO3 minus. Again with the -1 charge. A lot of them have -1 charges. HNO3 is nitric acid. Okay, so we have looked at these different classes of compounds separately, but there's going to be a proficiency quiz on nomenclature where you need to be able to write names from formulas and write formulas from names, and they're all going to be jumbled up. They're not going to say, write the name of this acid. They're just going to give you a formula and ask you for the name. You have to recognize what kind of a compound it is so you can use the right set of rules. So this will help you. If you have a formula, look at the first element in the formula. If the first element is a metal, it's going to be an ionic compound. Use the rules for ionic compounds. If the first element is a non-metal, then it's most likely a binary molecular compound, unless it's starting with NH4. And sadly, none of my examples ended up having NH4 in them. What if we have something like this, NH4Cl? We look at the first element, we see, oh, it's a nonmetal. But could this be a binary molecular compound? How many elements are in that compound? three, right? Nitrogen, hydrogen, and chlorine. You could get creative and come up with a name for it, but it's not binary, is it? This is a polyatomic ion called ammonium, and so this is an ionic compound. That's the only exception we're going to find. If the first element is a hydrogen, you can name it as an acid. And if it has AQ after it, you really should name it as an acid. Some compounds, though, you can also name as binary molecular. And then there were two kinds of acids, and so students sometimes get confused about which system. Rick ate him before he could bite us, or the hydro prefix thing. So the oxy acids have oxygen in the formulas, and those names are derived from the oxyanion. The nitrate, phosphate, that's the Rick ate him before he could bite us. If it doesn't have oxygen in it, you're going to use the hydro prefix. What if you have the name and you need to figure out what kind of a compound is this? Well, if you see Greek prefixes, tetra or penta or di in there, most likely it's a binary molecular compound. There's a couple of exceptions, though. There's a couple of anions, dihydrogen phosphate. There's one called dichromate, so you got to watch out for those. But those Greek prefixes, binary molecular, and then double check. Does it have two non-metal elements in it? They both have to be non-metals. And the second word will end in "ide." Okay, so those are just kind of checks on the first statement. If you see Roman numerals, it's an ionic compound. The first element will be a metal, or it's got ammonium in it. If it starts with ammonium, ammonium phosphate, ammonium hydroxide, ammonium anything is ionic. If the name has the word acid in it, that's the easiest one of all. It's an acid. Then the question is, what kind of an acid? If it has that prefix hydro, if it starts with hydro, then there's no oxygen in it. It's just a binary acid. If it doesn't say hydro, then it's going to be an oxy acid. And the charge on the anion is going to tell you how many hydrogens you need. Okay, that's enough to make you really dangerous.